In this video, we will consider a more interesting code problem. This problem will require us to implement a faster than a naive solution, first then to debug it, then to stress test it, before we actually come up with a correct solution that will be able to pass all the tests in the testing system. So the problem is called the maximum pairwise product problem. In this problem, we're given an array or a sequence of n numbers, and our goal is to find a number which can be obtained by multiplying some two numbers from this sequence. So recall that our problem is given a sequence of n non-negative integers to find the maximum pairwise product. So the input to this problem consists of two lines. The first line contains just a single number n, which is at least 2 and at most 2 multiplied by 10 to the 5. The next line contains the sequence of n numbers, which are non-negative integers not exceeding 10 to the 5. So our goal is to output a single number, the maximum pairwise product. The page contains also two sample tests. For example, if an input to our program is a sequence of length 3 consisting of numbers 1, 2, 3, then the output should be of course 6, because this is just 2 multiplied by 3. For a slightly longer sequence of size 10, the output should be 140, and this is 10 multiplied by 14. So as usual, there is also a section that contains starter files, and let's again choose C++ as our programming language for this problem. This is how the starter C++ solution file looks like. So we start by reading the number n from the standard input. We then create an array or a vector of size n. We then fill in this vector by elements of our sequence, element by element, that we read from the standard input. We then pass the array numbers to the function max pairwise product that computes the answer to our problem. Let's see what is going on inside the function max pairwise product. So we start by initializing the variable result by 0, and we then go through all possible pairs of different elements. That is, we go through all possible I and j, where I is less than j. We do this by two nested loops. And for each such pair, we check whether the product of the corresponding two numbers is greater than our current result. And if it is, we update the result. Finally, we return the result. So this algorithm is correct for an obvious reason. The goal in our problem is to find the maximum pairwise product, right? So to do this, we just go through all possible pairs and select the maximum product. Okay, to check that it is indeed correct, let's, as usual, compile it. So for this, we use the compiler Flux for C++. Okay, and then we test it. For example, for the sequence of length 3 consisting of numbers 1, 2, 3, the answer is 6. Let's test it one more time. For example, this sequence of length 5 consisting of numbers 3, 4, 5, 1, 2. So the answer is 20 as expected, because this is the product of 4 and 5. Okay, so it seems that this solution is correct, and let's just go ahead and submit it as a solution to the testing system. So I've just submitted our current solution to the grading system, and unfortunately it haven't passed all the tests. In particular, there is an error message shown in the grading system. Let's take a look. So it says that our solution failed test case number 3, which consists of just two numbers. The first one is 10 to the 5, and the second one is 90,000. Let's check whether we can reproduce this behavior on our local machine. So let's call our program with just two numbers, 10 to the 5 and 90,000. So indeed, as a result, instead of getting 9 billions as we would expect, we got some random number. So this usually happens when there is an integer overflow. And indeed, so we use the standard integer type for storing the result of multiplying two numbers, while 9 billion is too much for the integer type, so it doesn't fit into the integer type. So what we are supposed to do is actually to use the long C++ type. So let's do this and check whether this will fix our problem, our solution. So for this we need to change all the places where we compute the result, compute and store the result. So first of all, we change the declaration of this variable. We change also the type of the returned result. When computing the product of these two numbers, we first cast, for example, the first one to the long type. Okay, and also here. Great. Let's now compile it once again. Yes, and let's run it to check whether it correctly processes our previous data set. So 10 to the 5 and 90,000. Great. So it correctly outputs 9 billion. So now we must be completely sure that our solution is correct, because, well, first of all, to find the maximum pairwise product, we just go through all possible pairs and select the maximum product. So what can we do else? And also we now use the right type for storing the solution, for storing the result. So let's go ahead and submit our new solution to the grading system. Unfortunately, our solution is still incorrect. So in this particular case, the output of the grading system is the following: failed case 4, time limit exceeded. So it means that our solution is quite slow, that for large data sets it runs in more than 1 second. So let's try to understand why it so happens. First of all, the maximum size of a data set, the maximum size of a sequence for this problem in our case is roughly 10 to the 5. So what is the number of operations performed by our algorithm on such a sequence? So recall that in our algorithm we just go through all possible pairs of input numbers. So this is roughly n squared. So when n is equal to 10 to the 5, this is 10 to the 10. And this is more than 1 billion, and 1 billion is roughly the number of basic operations that modern computers can perform in 1 second. So we conclude that we need a faster algorithm to solve this problem. In particular, we realize that we need to find the maximum pairwise product without actually going through all possible pairs of numbers. So in search of an inspiration, let's take a look at the problem page. In particular, let's review the second sample case. In this case, our input consists of 10 integers. And the output in this case is 140. And why is that? Well, this is just because in our sequence there are two numbers, 14 and 10. And these two numbers are two maximal numbers, actually. So for any other two numbers, their product are less than 140. So this gives us an idea that to find the maximal product of two numbers from our sequence, it is actually enough to find two maximal numbers in our sequence. This is because all our integers in the sequence are non-negative. So let's just implement this idea in our C++ file. So this is already implemented and it looks as follows. So the new function is called max pairwise product fast. So it already uses the long type for storing the result, and we do the following. Just by scanning the input array 2 times, we find two maximal numbers. So in the first block we find the first maximum and we store its index in the max index variable, and in the second block we find the second maximal element. So the difference in the second block is that we also need to skip the first maximal element while scanning the array. So we do this in this check. Okay, and then in the end we just return the product of two maximum numbers in our array. Right? Let's as usual compile it and see that everything works correctly. So this is our new file, max pairwise product fast cpp. We compile it and we first run it on some small sequence, for example of size 3, for example 2, 3, 4. It gives us 12 as expected. Right, now let's do the following. Let's check what is the running time on a huge data set. So for this, let's, instead of reading the data from the standard input, let's just generate a huge array here. Let's use vector of int of size 10 to the 5 and let it be an array filled by zeros. Let's compile it and let's run it. So it outputs 0 immediately, which means that it is much faster than the previous algorithm. So now our solution just must be completely correct. So it is fast, it uses the right type for storing the solution, and it is also obviously correct because, well, it selects two maximal numbers, right, and multiplies them. No other product of two numbers can be larger because we selected two maximal numbers. However, unfortunately, even this solution is not correct. So you can submit it to the testing system and see that the output will be wrong answer for some test case. In the next video, Michael will tell you about stress testing and will show you how to fix this solution.